Hi friends, in today's session we'll be discussing about non-destructive testing, which is popularly known as NDT. NDT plays a big role in keeping all the missions safe and is used to test many of the components that we come in contact with every day. NDT means parts and materials are tested or inspected without causing damage to them. We'll be discussing the different types of non-destructive testing methods, their principles and applications. NDT offers various job opportunities in India or abroad. If you are interested in working in a dynamic industry, then NDT is the right choice for you. As a career field, NDT offers many opportunities and there is a big demand for engineers trained in NDT because of high demand and low supply. Always there is an ample of opportunities in this field. Before we understand about non-destructive testing, let us understand what is inspection. Inspection is a process of checking the dimensions, forces that a component can withstand, as well as determining the defects. There are different types of inspection methods. Basically, a dimensional inspection, also called as dimensional metrology, evaluates the geometric characteristics of machined parts and products to verify their compliance with design specifications. Micrometers, screw gauge, vernier calipers are used during the process. The next type of inspection method is metallurgical inspection, which is a process used to check the composition of an unknown metallic substance. The metallurgical testing typically uses microscopy to provide important information about the structure and properties of the materials. There are destructive process as well as non-destructive process in metallurgical inspection. Optical microscope and scanning electron microscope are usually employed during this process. The next type of inspection method is mechanical inspection, which is a technique used to ascertain both the physical and mechanical properties of the components. This is mainly employed to find the strength of the component. This method is a destructive testing method, where in this method the component is destroyed or it changes the part in some way such that the part is no longer fit for the service. Some of the mechanical inspections include tensile testing, compressive testing, bending, and so on. The next important type of inspection technique is non-destructive testing, where this is mainly employed to find the defects in the components without changing the structure of the components. The internal defects like blowholes, cracks can be determined using this method. Let us understand why we'll be using non-destructive inspection widely in the industries. If the components are too precious to be destroyed, as you see in the screen, or if we need to reuse these components after inspection, or if the component is in service or in operation, or for quality purpose such as finding the defects or cracks in the components, non-destructive testing is employed in the industries. Non-destructive testing means parts and materials are tested or inspected without causing damage to them. It is a method to evaluate properties of the materials or finding the defects or discontinuities without causing damage to the original part. There are different types of non-destructive testing methods. Visual inspection, fluorescent particle test, popularly known as liquid penetrant test, magnetic particle inspection, ultrasonic inspection, radiography, eddy current inspection, as well as holographic inspection. We'll be looking into these various methods in detail. Visual inspection is the most basic level of inspection technique. Here, only macroscopic defects can be determined. The part is illuminated with light and is examined with eyes. Various surface defects like cracks, porosity can be found in this method. Usually, magnifying glasses are mainly used during visual inspection. Fluorescent penetrant inspection is a non-destructive testing method that is used to detect surface cracks in the parts. Let us now understand the complete process. Fluorescent penetrant inspection is also called as liquid penetrant testing or dye penetrant test. This test is one of the oldest and simplest NDT methods, where its earliest versions dates to 19th century. This method of inspection is used for testing ferrous and non-ferrous materials like metals, glass, ceramics, rubber and plastics. The process is most widely used NDT methods because of its ease and flexibility. The process is preferred for the parts with discontinuities which are open to the surface. The various steps in this process involve surface preparation, application of the penetrant, penetrant dwell, where the penetrant is allowed to soak such that it enter into the crack, remove the excess penetrant, application of a developer, and inspecting the component. Let us understand each stage in detail. Surface preparation is the most important step in the process. The surface must be free of oil, grease, water and other contaminants. The part to be inspected has to be cleaned thoroughly to remove oxides and other impurities for the efficient detection of the defect. The next important step in the process is application of penetrant. A penetrant is a liquid of low viscosity which is capable of entering into the crack through capillary action. This can be done by either dipping, brushing or spraying as shown in the figure. After a certain time, the penetrant enters into the flaw due to capillary action. Once the penetrant is applied, it is left on the surface for a certain time so that it is drawn into the defect. Penetrant dwell time is the total time that a penetrant is in contact with the part surface. The penetrant easily enters the flaw due to capillary action and due to low surface tension. Dwell time usually ranges from 5 minutes to 60 minutes. Later, the excess penetrant will be removed on the part surface either by washing with water or a solvent. Then it should be dried with air. Care should be taken not to remove any penetrant from the flaw. The next step in the process is application of developer. A liquid developer is applied on the surface and the role of the developer is to pull the trapped penetrant material out of the defects and spread it out of the surface of the part so that it can be easily seen by the inspector. That is, the developer just acts like a blotter where it draws the penetrant out of the flaw. Later, the part is carefully inspected in the dark enclosure under ultraviolet or black light. The blotted out fluorescent particles will give a visible glow under ultraviolet light, revealing the presence of defect. Let us have a quick recap of the process. In this process, the test space has to be cleaned. Later, a penetrant has to be applied on the specimen. A sufficient time has to be given to the penetrant to enter into the crack due to capillary action. Later, the excess penetrant has to be removed. Care to be taken at this situation that the penetrant should not be removed from the crack. At the later stage, a developer has to be applied on the top of the specimen. This developer acts as a blotter. It draws out the penetrant wherever there is crack, thus making it clearly visible to the inspector. Fluorescent penetrant inspection is the most effective method to determine the cracks or discontinuities which are open to the subsurface. Let us now discuss various advantages and limitations of this process. This process is simple, easy to use and economical. There is no need for skilled inspectors as anyone can try to do this process. This process can be employed to inspect both ferrous as well as non-ferrous materials. The flaws are clearly visible to the inspector, making it easy to determine the defects. It has also got few disadvantages, being the cracks which are open to the surface can only be inspected. If the cracks are below the surface, the penetrant cannot enter into the crack, so that the process cannot be used. The surfaces should be extensively cleaned. This is most important so that the penetrant can enter into the cracks due to capillary action. The penetrant can stain the cloths. With this advantages and disadvantages, the fluorescent penetrant inspection is one of the oldest technique which is used in the industries. Magnetic particle inspection is a very popular low-cost method to perform the non-destructive examination of ferromagnetic materials. Let us now discuss in detail the process of magnetic particle inspection. Magnetic particle inspection is mainly used to detect the flaws in ferromagnetic materials. It has a capability of detecting the surface defects as well as subsurface defects. Unlike the previous process, the flaws which are below the surface can also be detected by using this process. This process basically works on the principle of magnetic flux, which leaks out of the surface in the presence of discontinuities. Surface preparation is the basic process which has to be carried out during any NDT process, which basically involves cleaning the component which has to be examined thoroughly so that oil, dirt or any other impurities will be removed from the surface. The next step in the process is to magnetize the component to be inspected. The test site is to be magnetized with a device called as yoke. A yoke is a device that creates magnetic field that is transferred to the part. It consists of an electrical coil which converts the electrical current into magnetic field. This magnetic field is transferred into the test piece through adjustable legs. The process makes use of either AC or DC power source. Once the component is magnetized, a magnetic field is developed in the component. As soon as the component is magnetized using yoke, the magnetic particles, usually iron oxide in the form of dry powder or suspended in oil, is applied on the surface of the component which is to be tested. Let us understand the basic principle of this process. Whenever the component is defect free or it does not have any cracks, then it will transfer the magnetic flux without any interruption throughout the component as shown in the figure. If the component has a crack or any other discontinuity, then the magnetic flux will leak out of the component, thereby attracting the magnetic particles near to this region of defect, thereby giving a clear visible indication of the defect. It is to be noted that in this process, the magnetic flux will leak out of the component only if the discontinuity is perpendicular to the flow of magnetic field lines. If the discontinuity is parallel, then the magnetic flux will not come out of the component. So in such cases, there will be no leakage of flux and hence there will be no indication of discontinuity. To avoid this, the component has to be examined by making the electric current flow in different directions. Let us quickly revise the process before ending up the session. The initial stage will be preparing the surface, where the surface has to be cleaned. This can be accomplished using detergents, organic solvents or other agents. The main aim is to ensure that the oxides from the area has to be removed. In the next stage, the part to be examined has to be magnetized by using a yoke. Once the component is magnetized, the ferromagnetic particles will be placed over the entire area. The excess particles are removed by gently blowing air over the particles. A careful inspection can reveal the cracks at the surface. Here we will be interpreting and evaluating any indications of the discontinuities. The previous steps will be repeated by rotating the yoke by 90 degrees so that the cracks which are perpendicular to the magnetic field can be identified. Once the process is over, clean the entire part, remove the excess particles and try to demagnetize the entire component if it is necessary. The same process we will be trying to understand by the actual demonstration. During the process, the plates to be inspected are magnetized using a yoke. Iron oxide powders are gently placed over the area. The excess material is blown off. If there is any discontinuity, the iron filings will be attracted near the discontinuity. Now, if there is no discontinuity, we don't observe any iron filings in the same location. If you can clearly observe, there is a cluster of iron filings in this area indicating the presence of a crack in this area. That is how the magnetic particle inspection has to be carried. Note that the inspection has to be carried in such a way that the crack will be exactly perpendicular to the magnetic field lines. Some of the practical applications of magnetic particle testing can be seen in the screen. The yoke is portable, and you can also observe the accumulation of iron filings near the defect area. Let us now discuss the various advantages and limitations of this process. This process can detect surface and near surface defects. The surface preparation is not very much important in this process, as most contaminants will allow magnetic field to pass. The method is faster compared to the dye penetrant test. In this process, the indications are visible directly onto the surface, and these indications can show the exact shape and size of the discontinuity. Let us now understand the various limitations of this process. This process can be employed only for ferrous materials, and non-ferrous materials cannot be inspected using magnetic particle testing. Limited subsurface discontinuity detection capabilities is the major drawback of this process. If the crack is in between the component, this process cannot identify such cracks. The post-demagnetization is often necessary during this process, and most importantly, the part has to be examined in different directions to detect the cracks which are perpendicular to the magnetic field. Thank you for watching this video. We'll meet in the next session with another non-destructive testing method. You can reach me at the mail ID mentioned in this video. Thank you. Have a nice day.